Greetings from Alan AI. Even if you are developing a voice assistant for the simplest app, most probably your solution will be backed by a database where you will store all the information needed. To be truly dynamic, flexible, and adapting, your voice assistant should be able to fetch data at runtime and save the information it retrieves from users' utterances during the dialog. Let's see how to use a database with your voice solution. We will leverage the Realtime Database provided by Google Firebase. Heading over to the Firebase portal and creating a new project. Once ready, we will switch to Realtime Database and add a new instance here. And at first we will start in the test mode, so our database will be open for all read and write requests for anyone using our voice assistant. In your project, don't forget to update these rules within the next 30 days. Otherwise, after the expiration date, you won't be able to access your data. The database is empty, so we need to import some sample data from a JSON file, for instance, user details. With the database setup, we can switch to the voice script in Alan Studio and add some logic for our voice assistant. To get and write data to the database, we will use the REST API provided by Firebase. Let's start with fetching the data. We will copy the endpoint URL, add it to our voice script, and replace the placeholder with the URL for our database. Now let's add the getData function to our voice script. In here, we will leverage the built-in access client to send a request to our database, get the user's data, and write it to Alan Studio logs. And we will also log an error in case it occurs. Now we will call our function to check what it outputs to logs. The next step, let's greet the user and call the user's name when the dialog is started. We will add the p parameter to the function to be able to use pPlayInit. Let's check it now. Hello, Alan.
Hello, Jack, welcome back.
Let's move on and see how we can write data to the database. Let's say we want to allow our users to update their personal details with voice. For that, we will use the patch request and at first define the endpoint for our request, which is a little different from the get one. Next, we will add the write data function. Here, we will again use Axios to send the request and update the user's data. If an error occurs, we will log it. And now we can add an intent to capture the user's address, play it back, and then call the write data function to save the address to the database once this intent is matched. We can test it. My address is 17 Lynn Avenue.
Got it, 17 Lynn Avenue.
And checking the Firebase console, we got it. This works well, but a database fully open for read and write requests from anyone is a really bad practice to follow. In the real world, you will have some sort of authentication set up in your app that will provide your users with restricted access to their data. Let's see how this works with Alan AI. We need a client or an app. Let's keep it simple and create a web page with the Alan button. We will go to Integrations, scroll down, click Copy All, and save the copied code as an HTML page. Making it look nice and checking it. Let's integrate our web page with Firebase and host it. We will go to Project Settings, create a new app, register it, and choose to host it with Firebase. Next, we will add the Firebase SDK to our page and install the Firebase command line interface. Once this is done, we can move on to hosting tasks. We will run a set of commands to log in, initialize the app, and then deploy our page. And finally, we will place our page to the public folder and deploy it. Let's check it. Hello, Alan.
Hello, Jack, welcome back.
Next, we will set up Firebase authentication. In the Firebase portal, we will switch to authentication and add a couple of users, say Jack and Anna. Each of our users gets a unique user ID. Let's update the data in our database. In the users tree, we will have the data for these two users stored under their IDs. And we will change the rules to let our users access only their nodes in the tree. Again, you can find links to the Firebase documentation on how to do this in the video description. If we now update our endpoint URL in the voice script and try to get some data, we will get the unauthorized access error. So let's allow our users to access their data in the users tree. If we take a look at the Firebase documentation, we will see that there is a possibility to send authenticated requests on behalf of the user currently logged into your app. To do this, we need to add the user's token to our endpoint URL. So our next steps will be adding a way to authenticate users in the app, generating tokens for users, and sending these tokens to the voice script to make requests over the REST API. To our app, we will add a new function that will allow our users to sign in with their emails and passwords. When this function is called, we will generate and return a token for the user whose credentials are passed in. Next, we need to pass the token to the voice script. For that, we can use Alan's auth data predefined object. With this object, you can pass any type of authentication or configuration data to the voice script when the Alan button is initialized in your app. Let's define the userconfig.json object in the app. With it, we will pass the generated token and the ID of the user who has just logged into the system. And we will add the auth data parameter to the Alan button block to pass our object to the script. Let us test it. In your app, you will definitely have a sign-in form to capture the user's email and password. But here, for simplicity's sake, let's simply pass these values directly to our function. And of course, don't forget to push all the updates with Firebase. On the voice script side, we will add the onCreateUser callback. When a new user runs the app with the Alan button and signs in, we will write the user's token and ID to Alan Studio logs. Works well? Now we can simply update the endpoint URL to add the token and ID as parameters and try our intents in the app. Hello, Alan.
Hello, Anna, welcome back.
The data is now coming back and forth. Let's use it for some nice scenarios. We will assume that in our food ordering app, we want to offer the user's favorites when the dialog is started. We will add favorites for each user in the database and update the getData function to place this list when the user opens the app and asks, "Hello, Alan, do you have anything for me?" Checking it with Anna. "Hello, Alan, do you have anything for me?"
Hello, Anna, welcome back. How about some of your favorites? Black tea, green tea, espresso.
And with Jack. "Hello, Alan, do you have anything for me?"
Hello, Jack, welcome back. How about some of your favorites? Cappuccino, latte, hot chocolate.
Designing a customized and personalized voice user experience with Alan AI is easy. Subscribe to our channel and comment on what you would like to see next.